This counting video is going to be focusing on adding the sum of large positive integers. And when I mean adding, this is not like simple adding, simple addition. This is going to be sum of consecutive positive integers. So let's get started. So let's say we have a sequence that is 1 plus 2 plus 3 plus 4 all the way to 100. Now we want to compute the sum of this. This is not just, we could just try adding everything up, but that would take forever. So we're going to find a better way to do this. Now there is a formula for this, but before we get to that, we're going to try to get close to deriving this formula. So we're going to start with the sum of 1 plus 2. Two consecutive positive integers, sum of them, and obviously this is just 3. But as we focused on, like in the last video, an example would be like we saw a permutation with repeated elements, and we knew how to handle the problem. We knew how to solve the problem, but we figured out how we could get to this solution in terms of larger and more challenging problems like this one. So we have a 3 here. 1 plus 2 is 3. 3. So over here, what we're basically doing is we need to find a pattern here, and we can see like it's 2 greater than the first digit, but that's not going to help us because 2 plus 3 is 5. 2 plus 3 is 5, and now the difference is greater, so that's not going to help us at all. Now we could multiply. If we multiply 1 by 2 and we add a 3, add a 1, that needs to work for 2 plus 3 as well. We'll multiply by 2, add a 1. It seems to be working here. Sum of some consecutive positive integers. And let's say we had a 3 plus 4. We know it's 7, but we're going to find out how we get there. 3 times 2 is 6. 6 plus 1 is 7. So we see a pattern that is starting to work out. But let's see in terms of 2 how we can solve this. Because if we use this method on this consecutive positive integers all the way to 100, it's not going to work too well, because here we have 1. If we multiply 1 times 2, that's just going to give us 3, so that's not going to work out. So our method here works for consecutive positive integers where there's 2 numbers, like 2 plus 3 and 7 plus 8. It works. We know it worked for a couple. But again, when we have 7 plus 8, 7 times 2 is 14, which is not even close to 8. So our method is not going to work out. So this solution is not going to work out. And now, let's go to 2. We know 3, the solution is just 1 greater than 2, but that's just a special case. So we're going to ignore any special cases. We know that 2 multiplied by 2 is 4. 4 minus 1 is 3. Let's try that with 2 plus 3. We want to find in terms of 3. 3 times 2 is 6. 6 minus 1 is 5. So it is working here. Let's try it with 7 plus 8. 8 times 2 is 16. 16 minus 1 is 15. Another bigger number. So it is working. 10 times 2 is 20. 20 minus 1 is 19. Now, here we have a little bit of a more challenging type of thing. We have more than just 2. So it's like 1 plus 2 plus 3. And we obviously know that this is just 6. But we're going to find out how we got to this. And it isn't immediately obvious how you get to this, because if we're following the example over here, we just multiply the last thing by 2, we double it, and then we subtract a 1. That's not going to work over here. We need to find a more general way. So 1 plus 2 plus 3 is 6. Let's see in terms of 3. So 3 times 2 is 6. 6 is a multiple of 3. That's not too unobvious. Let's try 2 plus 3 plus 4. So now there's no multiple, like no proportional relationship between 4 and 9. So we gotta think of a better way. 4 times 2 is 8, and 8 plus 1 is 9. That's a great way. But over here, 3 times 2 is just 6. So that's not going to work either. So we don't know when to add 1, or that's not going to work out. We need a method that will work every single time. And a way we can do this is focusing the numbers around 1 plus 2 plus 3 or 2 plus 3 plus 4. So we can go a little bit down. We can check a 0, but the 0 is not going to help us too much. We can check out 1, 2, 3. We can check out the number greater than 3, which is 4. So 3 plus 4 is 7. 7 minus 1 is 6. So that works for now. 4 times 5 is 20. Then no, it's not going to work out for every single time. Let's try multiplying. So 2 times 3 is 6. These two numbers. 3 times 4 is 12. That's not going to work out. 3 times 1 is 3. That's obviously not going to work out. Here, you can add a 1, but that's not going to work out because here it won't work out. So we know it's not going to work out over here. So our last resort is just multiplying 3 by the number right above it. I think that's what we're going to do. So 3 times 4 is 12. And 12 is surprisingly a multiple of 3. This seems to be a coincidence, but we're going to try it over here. 4 times 5 is 20. And 20 divided by 2 is 10. So it's not all. So 4 times 5 is a 20. And a 20 divided by a 2 is going to be a 10. And that's 1 plus the 9. Let's see if it works out for the sum of 2, 3, 4 plus 5. Right here we have 3, 6, 10, 15. 5, 6 is 30. 30 divided by 2 is 15. So it is correct. And if we add a 6 to this, 15 plus 6 is 21. 6 times 7 is 42. 42 divided by 2 is 21. So this is working for not even, but this is working for integers. This is what we know this is going to work for numbers. We know this is going to work. And the reason, we notice the reason this does not work is because there's no 1. In all of these cases, we're doing 1 to some number. This is not a 1, so this is not going to work out. So we notice that our method, our formula is working. And we can define this as over 2 x multiplied by x plus 1, the number above it. And x is the largest number in the list. So back to our original problem here. We have a bit of a challenge here, but so we're going to erase everything here. And we're going to go ahead and focus on this problem. So immediately I see a 100 as our greatest number. And 100 plus 1 is 101. And then we just divide by 2. So that is going to be our answer. However, we do want to simplify this a little bit. So I know that 101, when I multiply that by 100, I'm going to get something like this, 10,100. If I divide that by 2, I know that that's going to be a 5. That's 2, 0, and that's going to be a 5. And if I just divide that by 2, yeah. So that's what I'm going to get if, yeah, alright. So our answer is 5050. So the sum of the first 100 consecutive positive integers is 5050.